Welcome to this video on unbiased sampling methods. By the end of this video, the student will be able to define the terms population, sample, census, and inferential statistics. The student will be able to explain why samples are used to collect data. The student will be able to list 4 methods of unbiased sampling and to identify which of the 4 methods of unbiased sampling is being used in a given example. Let's begin. First, we need to define the terms population and sample. A population is the complete set of all measurements or data that are being considered. A sample is a proper subset of members selected from a population. This means that the sample is smaller than the population. Why do we sample? Collecting data from every member of a population is called a census. Many times it is impossible or impractical to collect information from every member of a population. Instead, we collect data from a representative sample of the population and then make inferences about the population based on the information from the sample. The process of making inferences about a population based on a representative sample of the population is called inferential statistics. Consider this. Suppose a certain brand of pain reliever claimed to be the #1 doctor-recommended treatment for headaches. Do you think that the makers of this drug surveyed every doctor in the world in order to support this claim? Why or why not? If you want, you can pause the video and think about this before continuing to hear the answer. The answer is clearly no. It's not practical or even maybe possible to survey or collect data from every doctor in the world. Therefore, most likely, a study was done on a sample, which was hopefully a representative sample of doctors, to make this claim. Here are some sampling rules that we have to follow. If we are sampling without replacement, our sample size must be less than 10% of the total population if we wish to treat samples as independent. In order to collect random, unbiased samples that are representative of the population, every member of a population must have an equal chance of being selected. Another way to express this idea is that every possible sample of the size we plan to draw has an equal chance of being selected. Suppose at the end of a meeting you attend, gift baskets will be given away as prizes. You are excited and hope to win. After the meeting, you are all ready to find out if you won a prize or not. The meeting host announces that anyone with a birthday in January wins a gift basket. The meeting was being held in January, and that's why that month was chosen. Does this method of sampling offer every person at the meeting an equal chance of being selected to win the prize? Pause the video, think about your answer, and then unpause the video to see if you agree with what I'm saying. Does every possible sample of the size we plan to draw have an equal chance to be selected? The answer is no. If instead what the meeting person had done was to put all 12 months into a bag and randomly choose 1 month from that bag, this would have been a more random process. An even more fair way would be to take everybody's name and put it in a hat. Maybe if people attending the meeting were wearing name tags, you could put all the name tags in a bag and draw a certain number of names out of the bag. That would give everyone an equal chance of winning. Let's look at some unbiased sampling methods. Several methods of unbiased sampling have been formalized and given their own names. They are as follows: simple random sampling, which is sometimes abbreviated SRS, stratified sampling, cluster sampling, and systematic sampling. We will explore each of these methods in detail in the coming slides. In simple random sampling, we have to find a method to randomize our selection. Remember, that means that we have to give each member of the population an equal chance of being chosen. Some examples would be picking names or items out of a hat or a bag or a box, or using a random number generator on a computer. For example, suppose the mayor of a city wants to find out his popularity among his constituents. Constituents means the people he represents or the residents of the city. To create a random sample, he could obtain a list of all the residents and then use a computer to randomly select a sample of the constituents to survey. This is an example of simple random sampling. Let's look at stratified sampling. Sometimes the population is first sliced into homogeneous groups called strata before a sample is selected. Then simple random sampling is used within each stratum before the results are combined. Suppose the mayor of a city wants to find out his popularity among his constituents. To create a stratified sample, he could first divide the city into districts and then collect a random sample from each district. This is an example of stratified sampling. Let's look at cluster sampling. Sometimes stratifying isn't practical, and simple random sampling may be difficult. Splitting the population into similar parts or clusters can make sampling more practical. Then we select one or a few clusters at random and perform a census within each of them. Remember, census means we collect data from every member of the population. So in this case, we would be collecting data from every member of the cluster. We select clusters to make sampling more practical or affordable. In this example of a mayor wanting to survey his constituents, he would still divide his constituents into different districts. However, instead of collecting random samples from each district, he would select a few districts and collect data from all residents in these districts. The last method of unbiased sampling that we want to discuss is systematic sampling. Sometimes we draw a sample by selecting individuals systematically. For example, you might survey every fifth person leaving the library. When there is no reason to believe that the order of the list could be associated in any way with the responses sought, systematic sampling can give a representative sample. Systematic sampling can be much less expensive than true random sampling. Going back to our example of a mayor who wants to measure his popularity, he could use systematic sampling by obtaining a list of all residents and surveying every 100th person on the list. Many times, students will confuse stratified and cluster sampling because they are so similar. In both types of sampling, the population is divided into smaller groups, but this is where the similarity ends. In stratified sampling, we sample some members of every group, whereas in cluster sampling, we are sampling every member of some groups. Let's look at this example and determine whether it is an example of stratified or cluster sampling. Suppose you want to test for quality control in a cake that has just been made. You cut the cake into 8 equal slices, then you take one bite that is randomly placed somewhere on the slice out of each of the 8 slices. Is this an example of stratified or cluster sampling? Pause the video, write down your answer, and then see if you were correct. The answer is stratified sampling. Because we are sampling some members of every group, this is an example of stratified sampling. Let's look at another example. Again, we have a cake that has been cut into 8 slices. We randomly select 2 slices of this cake and eat them in their entirety. Is this an example of stratified or cluster sampling? The answer is cluster sampling. In this example, we are sampling every member of some groups. Notice that we're not touching or tasting the other 6 slices of cake. We're only looking at 2 slices of cake. However, we are conducting a census of those 2 slices by consuming each slice in its entirety. Let's do a few more examples to get comfortable with these sampling methods. To determine the average wait time at a bank, a statistician measures the length of time every 9th person coming into a bank waits for teller service over a period of 2 days. What type of sampling is used here? Pause the video, write down your answer, and then see if you are correct. The answer is systematic sampling. A pregnancy study in Baltimore randomly selected 15 communities from the metropolitan area and then interviewed all pregnant women in these 15 communities. What method is being used? If you said cluster sampling, you're correct. In order to form a committee, a manager divided her employees according to rank and then selected a random sample from each group. This is an example of stratified sampling. To collect data on a certain TV show, a study group called randomly generated telephone numbers. This is an example of simple random sampling. A study group divides the population of interest into groups based on geography: north, east, south, and west. They then randomly select survey respondents within each of these 4 regions. What type of sampling method is being used here? If you said stratified sampling, you are correct.